We assume the ground that we walk upon is stable, and in places like London, it feels very solid, very permanent. But when a place has as much history as this, is that necessarily true? London sits on layers of engineering and soil and rock. So today I'm going to walk you through why some of this is important and how it is still very much moving. London's geology is actually relatively simple. The first layer that we always seem to encounter is made grounder. Next is the river terrace deposits. These are exactly like they sound. Think gravels and sands in a stream bed. Bit of vegetation, gets made to peat, etc. Below these river terrace deposits, we have the London clay. Now this deposited about 50 million years ago, and engineers love it or love to hate it because it is very monotonous and it goes on for a long way. Also, hard rock. Like rock? Yeah, okay, I'm walking. In fact, it's thanks to this clay that London has managed to turn into the city it has. Basements, tunnels, underground structure. A lot of this has the clay to thank. I get it. Clay might not seem silver screen worthy, but it's played an incredibly valuable part to something that has made London, and that is thanks to the London Underground. When engineers started building the tube lines in the early 1800s, they discovered something very useful. The London clay holds up. See, the London clay is firm enough that it stays up for a while when you excavate it, and adds this waterproofing so the tunnels don't fill with water instantly. See, if they'd tried to build the London Underground through a sand, they would have struggled. Waterlogged sand would rush into an excavation, so London would look very different if we'd had 100 metres of that instead. So, we get it. We love the London clay. But of course, each excavation removes some material, and this is de-stressing the rocks around it, etc. So you see how it quickly becomes an engineering problem. Normally this effect is tiny and managed carefully through engineering design. There was some very cool mapping done a few years ago using a very interesting and very intricate satellite called Sentinel-1. A company called Geological Ventures built a map of the UK, marking out regions of unusual uplift and subsidence. They attributed this brown blob over Kennington to the digging of a vertical tunnel or shaft as part of an extension of the Northern Line. According to this, about 8 millimetres of movement. Although this looks dramatic, we are actually able to deal with things when a whole area settles in the same way. It's only when we get uneven settlement that engineers start getting a little bit more nervous, shall we say. But this is the point of an engineering geologist. Engineering geologists will investigate, map, monitor all of the potential issues that might go wrong with a site, try and risk it away so that we make sure we do it in a way that doesn't damage things or cause issues. Getting off the main streets, the public humiliation of talking into a camera it's something. I'm used to nice beaches where there's no one around. But I'm cutting down here to show you something else. So, keep going south, and I'm heading towards the Thames. So here, I'm in Victoria Embankment Park, and this gate behind me shows just how far the water used to come. You'll also see it's much lower than the surrounding park. So when you excavate all this soil from a tube line, where does it go? Well, you build an embankment with it, and the embankment here was built with the soil out of the district line. And as you can see, so behind me here is the gate, and far on the other side of the park is where the Thames is now. So this is the old Watergate here, and a depiction that shows you it was very, very much on the water's edge. Walking from here to the edge of the Thames, let's see how far it is. And here we are. That's the water, just the other side now. So while we're on the topic of water, that brings me to my next point. Keep going beneath that clay and you hit the chalk. And the chalk is very important because it's an aquifer. An aquifer is where water is stored all in between the little bits of rock. It's not like a lake, it's all hidden in all the little cracks and fissures in the rocks, as well as between the very pores of the individual grains themselves. In the 19th century and earlier 20th century, lots of industries pumped water out of this chalk, like breweries and processing plants. Now, when you remove water from an aquifer, the pressure that was holding that rock up just drops ever so slightly, And eventually, this leads to a little bit of subsidence in the land. Across central London, it's estimated that the ground level dropped up to a foot or 30 centimetres. So it was a noticeable amount, it wasn't nothing. In the 1970s, groundwater abstraction reduced, and this allowed the water levels to rebound. Now you see, this then started to create the opposite issue. We started having bits of ground heave, which is like push upwards. In the 90s, a lot of work was done to ensure that the groundwater levels stayed constant under London. Otherwise, it was going to start putting pressure on things like basements, tube lines, with water coming in where they weren't expecting it, and the ground starting to heave in ways that we weren't expecting. Groundwater levels in London are now very actively managed to make sure it doesn't drop too much, doesn't rise too much either. So, as you can tell, I'm now starting to walk past London's quite famous monuments, and there's a particular landmark, you might guess where I'm walking to, that was also had some fun issues. So a great example of another thing that's on the move is the tower just behind me, Elizabeth Tower, aka Big Ben. Measurements show it tilts about 0.26 degrees to the northwest, which in real terms is about 40 centimetres difference from the base to the top. Apparently this is just about visible, so let's see if we can find it. Do you know what? You just about can. I'm not sure how well it's going to come out on camera though. So it is leaning ever so slightly that way. I'm not sure if you can pick up on it. I'm trying to keep this very steady so you can look at straight lines of other buildings. But there is just a tiny, tiny tilt. Maybe it's just because I'm looking for it. I'm not so sure. So the reason for this tilt is attributed to lots of different things. Everything from construction to underground excavations, all sorts. Basically, they haven't committed to one thing that's caused it. However, you'll be happy to know that they have predicted that in order for it to reach Leaning Tower of Pisa kind of levels, we're looking thousands of years, so it's not going anywhere anytime soon. In fact, they're not even sure if it's going on like an annual rate or if it's stopped, so I don't know, check back in 20 years and see if it looks any different, I guess. So we've spoken a lot about humans, but is there anything we can let ourselves off for? So, letting humans off the hook a minute, there are some natural things at play here too, that more relate to geological time rather than just human time. During the last ice age, huge sheets of ice covered Britain. The thing is the ice sheets only really covered the north of Britain, not the south. That weight of ice pushed northern England downwards. So when the ice melted, the weight was gone, and therefore it started lifting back upwards again. Because remember, the mantle is liquid. Very dense liquid, but liquid nonetheless. So in response, whilst northern England is now rebounding and going up, southern England is sinking. Now how does this work? Because nothing was on in southern England in the first place. Well, let me get a drink and I'll show you. We're going to grab a drink in Waterloo because I've got an advance ticket and I don't want to miss my train. So, we have a drink and we have some ice. So this is going to represent my mantle. This is going to represent the crust on the top. So, as you can see, our crust floats beautifully on top of the mantle, sinks in a bit, it's a bit like an iceberg, but this is the little bit that we live on right on top. So when I load it with a glacier, one corner dips down, leaving the other bit up higher. So when I release that pressure, it self-rights itself. Now, is this an excuse for me to come and get a cider at the end of a long day? Maybe, but it does show you how the buoyancy works. So basically, the mantle is slowly flowing back to where the load used to be. And in turn, the southern bulge is falling back downwards again. So southern England isn't just randomly sinking independently, it's because of this bulge and then sink. Geologists call this glacial isostatic adjustment. The rate here in southern England is pretty small, it's only about 1 millimetre a year. And in the Highlands, on the opposite end, you've got about 2 millimetres a year of rise. You wouldn't notice it day to day, but it does add up over the centuries. So London might feel permanent, but beneath the streets, it's slowly adjusting to human influence, glaciers, water, everything that we throw at it. Together, all of these things remind us that London, whilst being one of the world's oldest cities, is still very much on a world that is constantly moving and changing underneath it. Cheers!